Hey guys, Script the Lazy Geek here and welcome back to the channel. There is a free new tool to do automated background extraction. And so I want to talk about that in this video. This tool is provided by a guy called Frank or Franklin from the SETI Astro YouTube channel, also website. And I'll put a link to his own video up above and also down in the description. I highly recommend checking out his channel. It's amazing and it goes into a lot of details, which as a geek, I love that. And this comes directly in competition to things like GXP AI. So there is a standalone free software, but that's also available as a plugin to PixInsight, called GXP that basically uses machine learning and AI to look at your astrophotography image and remove the background from it. If you're not familiar with astrophotography that much yet, basically when we take an image of a galaxy or a nebula, there's also light pollution in there, maybe moonlight kind of shining through or stray light from street lamps, whatever. And that can cause a gradient in your image. You want to be able to remove that gradient, and GXP AI, for instance, it will look at the image and say like, yeah, this part here is probably your gradient, the rest there is the nebula that you were trying to capture, so I'm gonna go ahead and remove the gradient for you. And you have barely any input into that, like the AI does everything on its own, which is great because it allows you to be lazy, but also not great because sometimes you're not quite sure what the heck that AI is doing. And historically, we've had other tools available for quite a while, things like automated background extraction in PixInsight and dynamic background extraction in PixInsight. In particular, dynamic background extraction relies on you, or me, the user, to select points on your image that correspond to the gradient or to the background. Basically, you tell the process, the software, that, okay, this point, that point, this point, and that point in my image are the background, and then the software figures a proper smooth background from that, subtracts it from your image, and you get a really good result. You have full control of what's happening, but that makes things a bit more time-consuming and difficult. So we have two extremes, GXP AI, which is fully automated, and then we have dynamic background extraction, which has equivalence, by the way, in GXP itself, or in free software like Cyril, where you have full control. There's no middle road until now using the SETI Astro plugin called Automated Dynamic Background Extraction. And as its name implies, it's basically dynamic background extraction that I mentioned earlier, except that the points that are supposed to show the software where the background is will be chosen automatically, not using AI, but using a very common mathematical algorithm called gradient descent. Now we'll go and have a look at how the plugin works and how it compares to GXP in PixInsight, so I'll show you that. Before that, this video is sponsored by Boolean.org and we'll talk more about that later in the video. Okay, we are in PixInsight and I have here three images that we're going to look at and compare: automated dynamic background extraction and GXP. So we have M31, the Andromeda Galaxy here, with quite a strong gradient here on the sides. We have the Cone Nebula, with like a left to right maybe gradient. Left is dark and right is bright, and maybe center is even brighter. And then we also have the California Nebula, where the center is brighter and then the edges are darker and redder. So we have gradients here, and we want to remove those. For that, we can use GXP either as a standalone tool or as a script or even as a process in PixInsight, and that's what I'm going to use. And we can use automated dynamic background extraction, that new script from SETI Astro. Again, I'll have all of the links down in the description. So first, how do you install those processes in PixInsight? If you use PixInsight, you go to Resources, you go to Updates, you go to Manage Repositories. And if you want to add the GXP process, you click on Add, you put in this URL here, which I'll put down in the description, and you click on OK. And then, in the same breath, you want to add automated dynamic background extraction from SETI Astro. And for that, you'll click again on Add. This time you add that URL, a different one, again, link in the description. Click OK. Once you're done, you can validate. You go to Resources, Updates, check for updates, and it will find the new plugins to install them, and then you'll need to restart PixInsight and they'll be applied. Okay, now that we're done, I'm going to show you how GXP performs on this Cone Nebula image, and then we're going to compare with the automated dynamic background extraction, and I'll show you some of the parameters that are available there. So, the Cone Nebula, here we are. GXP is available as a process, thanks to the install that we just did together. And these are the default options of the GXP tool, I believe. So smoothing of 0, so the background extraction is what we're going to use. We're going to ignore the denoising for now. And you have just a single smoothing parameter and then a correction tool that doesn't really change much of anything, but you can leave it at subtraction. And then you have a tool called Show Background. You absolutely want to click that, in my opinion. So keep it checked. It will show you what exactly background was removed from your image. And you'll be able to see that also in the standalone free GXP software as well. Now, with those options, what is the result on this cone nebula? The result is here on the right. So you can see this like weird background from left to right is completely gone. We have a very smooth image. At the same time, I feel like there's something weird going on. To some extent, the image on the left is prettier than the image on the right. And I'm not quite sure why. Let's look at what GXP did, because GXP saved the background thanks to the checkbox that we added. So here's the background. We have it here, and you can see there seems to be a lot of structure in this background. There's even this like random dot here, which seems to correspond to a bright area there. But wait, isn't that part of the nebula? Isn't that thing something we would want to actually keep, but GXP is removing? That's a bit worrisome. If you want to really check what's going on in there, Frank from SETI Astro has actually a good way to do that. It's to use a PixInsight tool called Automatic Background Extraction, and you want to just set the function degree to 2, because that's something that works well for vignetting and that kind of stuff. I'm not going to go into the details. You want to do a subtraction on your image, and you can discard the background model, even replace the target image, and then we can apply that to the background just to see what was going on inside the background. And this is what we see. So you can see here there's a lot that's going on. Actually having like a bright area in the center with bright areas in the outside with kind of a donut does not surprise me, because this image was taken with a telescope called the C6 Hyperstar that tends to have this kind of gradient. So that's good. But look at all of the weird structure that we have within the image. I am absolutely sure that this removed some nebulosity from the image. That's where, checking the gradient becomes very important when you're using an AI tool that you rely on. You trust the AI to do the right decision, but you want to double check, trust, but verify. Now, one more thing that we can do is go back to the GXP process there, or the software, and set the smoothing on the opposite side to 1. And that's what I usually recommend, using the smoothing of 1, because that's where the AI is the least aggressive and doesn't try to remove details from the image. And I find that it works most of the time. And with that, we get this result here, where I much prefer this result in general, because the image looks much smoother, and we're also keeping some of the nebulosity here. It feels slightly less as bad as it was before. We can compare the two. Like, the two images are quite different if you look at those details here, even in the details around the center of the nebula. So I find that very interesting. And that's why I would always recommend a setting of a smoothing of 1 on the background. And this is how the background looks like. Compared to what it looked like with the smoothing of 1, you can see it is very different. That's again why I would always choose a smoothing of 1. If we apply an automatic background extraction on the background just to see what's going on, now I see something that I really like. It just removed the background, like the normal shape of the C6 Hyperstar background, without doing much. So we're very close to what we want to do. Okay, but what about the new tool, Automatic Dynamic Background Extraction? Well, we can try to run it. So you go to Script, SETI Astro. This should be available now that you've installed the tool, and then you have Automatic Dynamic Background Extraction. That is available here. Now you can do a lot of things in there, but I found like the default options, they usually work quite well. You have a certain number of descent paths. This is basically going to give you the number of samples that will be automatically chosen, and you can see those samples, they're called descent path. They're not placed by AI or machine learning. They use a very common mathematical algorithm that is called gradient descent. And the tolerance is actually a setting from the PixInsight dynamic background extraction that tells how much we want to consider each point depending on the brightness of the point. But we can touch that later, not a big deal right now. We can just keep the default options, we can show the gradient extracted as well, and then we can execute on the image by clicking on execute. And this here is the result that we get. So original image on the left, the automated dynamic background extraction on the right, using just the default settings. If we compare it on the left to the Graxpert with a smoothing of 1 image, I actually kind of prefer the result that was gotten by the automatic dynamic background extraction script that does not use any machine learning or AI. It's a purely mathematical thing. We can have a look at the extracted background, and this is how it looked like. I can see there's maybe a bit more structure that I would like to see in there, but it's not too bad. The background with the automatic background extraction in there is also decent. It doesn't look too bad at all. So that's perfectly acceptable to me, and the image looks fine as well. We can run it with different parameters if we're not convinced, and we can see exactly what the script did. For that, I can simply go to the History Explorer and select my cone ADB image there, and double-click on Dynamic Background Extraction. It shows me exactly where the points of the background were chosen. And some of those points I can see they're very close to actual areas of luminosity, of nebulosity, so maybe they're not the points that I would personally have chosen. So for that, when you see that, you can close this and you can, rerun the script with different settings. I could go to the script, go to automatic dynamic background extraction, and maybe lower the tolerance so we don't, like I said, to 1, so we don't include all of those points at the same time. We could also lower the number of descent paths to say like, hey, you don't need that many samples for that particular image. And we could also define an exclusion area. So you click on this user-defined exclusion area, and then you can say like, yeah, hey, you can ignore this area there, don't place points there. Right? We're not going to do that, but that's one of the abilities. You can use shift, click, drag. Shift, click, drag to say like those, whatever is in those squares, do not put any samples in there. And I actually did a small change with just the tolerance, and we can even look at how it looks like with a different tolerance. So on the left, a slightly changed parameter of the automatic dynamic background extraction, and on the right, the original run. We can also compare the background to what was before. This is the new background, this is the previous background, and we can see there's probably a little bit of difference where we're slightly less going into the details in the new background. So you can really fine-tune what you're doing as well here. The background with the automatic background extraction looks like this. So this is all super interesting, and we can do very similar comparisons for the other images as well. Now, before we go into that though, you might be interested in how the heck does this work and what is gradient descent. So in a word, gradient descent is a technique in mathematics. If you have like a function or like a surface, you can imagine that you're on a mountaintop. It's very smooth, there are no trees or whatever, and you want to go down to the foot of the mountain and you don't have eyes or anything. The only thing you know is the slope in all of the directions around you. Well, if you want to find like the foot of the mountain, one method could be to find from the position you're at, the slope that is the steepest, do one step in that direction, and then you stop and you do that again. You don't look, but you feel around you for the steepest slope, and you go in that direction, and you go one more step in that direction. And then you do that again and again and again and again until you're at the foot of the mountain. There are issues with that, such as what we call local minima. I could reach a place where all the slopes are going upwards, so I'm at a minimum, I'm at a low altitude, but it's actually not the foot of the mountain, it's some kind of hollow on the mountain. So that's one of the drawbacks of a gradient descent type of algorithm. There are tons of ways that this can be mitigated, and gradient descent is actually used a lot in training AI models. So it's all very interesting. And by the way, if you want to learn more about all of that, it's a topic that I find fascinating. Or you just want to learn more about the basic math that underlie all of that, or physics, computer science, because you need to program that in the end. One of the best ways to do that is to use brilliant.org. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. And what I really like about Brilliant is that everything is super hands-on. There's always sliders and stuff on charts that you can move around to see exactly what's happening. And all of that is really focused on problem solving. Even like the lessons are typically arranged as an overall problem that we solve step by step with the lesson plan. So it really helps to remember everything, to understand everything, and at the same time to build problem solving skills. So we're learning beyond the scope of the lesson at the same time. And because it's fun and rewarding, I'm, developing a daily learning habit. I'm always on Brilliant almost every day, basically. And it only takes minutes every day to just be effective. One course I've been taking recently is the courses on probability. There's some new ones that have been added recently. And I thought I was really good at probabilities, but even in the introductory course, I made mistakes and I had to relearn a lot of stuff. So it's really perfect for learners of any level to start or to continue learning or to relearn stuff like I am. So there's a fully built suite of new content, and it goes from basic to really advanced. So if that also sounds fun to you and you want to try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/quivlazygeek or just click on the link in the description. You'll also get 20% off an annual premium subscription. Now, where were we? We were on the California Nebula. Here we are. So again, we can compare GXP with smoothing 0, which I like not to use, GXP with smoothing of 1, and then the automated dynamic background extraction for you AI haters out there. By the way, before we do that, what do you think of that already? Like, I find it super interesting. I'm really happy that we have yet a new way of doing like a background extraction that is very low effort, but is still more controllable than something that is purely AI based. Let us know down in the comments. While you're going there, take 1 second to like the video. It really makes a huge difference. And if you're new to the channel, you may consider subscribing and clicking that bell icon, in which case, welcome to the channel. If you're planning to buy anything from Amazon or any astrophotography equipment from Agena Astro or First Light Optics or High Point Scientific or even things like astroshop.eu or All-Star Telescope, and you do so after clicking the links that I have down in the description, you'll help the channel out at no cost to you, and it is very, very much appreciated. And if you want to support me even more directly, you can become one of my paid Patreon members, and some ranks have access to my videos early and without ads. Or you can become a channel member by just clicking the join button next to the subscribe button. This channel would no longer exist without my Patreon supporters and channel members. And with your help, I hope to keep going as long as possible, so thank you so much. Anyway, back to the video. Okay, California Nebula with this huge gradient. Let's look at the result with GXP and the smoothing of 0. At first glance, it looks quite good, right? It looks quite amazing, like really good result. On the left is the original image. On the right is with the smoothing of 0. If we use smoothing of 1, we get something slightly different. And you can see the smoothing of 1 looks like it was less successful. It left some red gradient on the left and the right sides of the image as well, compared to the smoothing of 0 that didn't. But if we look at the extracted backgrounds, we see a very different story. This is the smoothing of 1, and it looks perfectly fine to me. There's no like loss of structure in the nebula. This is the smoothing of 0. And there's definitely, look at that, there's so much structure in there that is being destroyed by GXP. And we don't realize it until we actually process the picture, or even we never realize it, because we will need to process the picture with the smoothing of 0 and the smoothing of 1. So appearances can be deceiving. What about our automatic dynamic background extraction? Well, with it, this is the result. And I find this very interesting because the automated dynamic extraction has managed to get rid of the gradients, but it still has those reddish areas across the picture. And that is a good thing, because I do believe those reddish areas exist around the target as H-alpha or hydrogen alpha jets outside of the main nebula body. This is something that the original GXP with a smoothing of 0 completely or almost completely nuked compared to automated dynamic background extraction. And while this was preserved in the GXP with a smoothing of 1, where we still see those red jets outside of the nebula, the smoothing of 1 was not able to remove the gradients here on the sides of the image. This is something that the automated dynamic background extraction was able to do. So that's a very good thing for it. Let's have a quick look at the background. This looks nice and smooth, and the background with an automated background extraction set on it. And we can see there's very much no details that have been taken. I'm a bit worried about like those really big red areas at the top and the bottom. And so we can have a quick look in the History Explorer at the California Nebula with the automated dynamic background extraction and look at the points that were chosen. But I do think that overall the points chosen were really good. They are all outside of the main nebula body. Maybe this one is something that I would remove. So we could actually, again, go in the automated dynamic background extraction tool and select this area there as a no sample area, or maybe even the whole body of the main nebula as a no sample area. That would work as well. And that's a good thing and a bad thing. We have full control, but with full control means we need to know what we're doing to some extent. Although this is just with the default settings, I didn't have to do anything, and it's free. Ha! And it's not relying on AI, because I know a lot of people hate AI. Okay, now let's look at our last image of the crop, which is M31, the Andromeda Galaxy. This is the original image, and let's look at what Graxpert with a smoothing of 0 did. So again, Graxpert with a smoothing of 0, it seems to have done an excellent job, right? There's no more gradient left whatsoever. It looks beautiful, it looks like everything is nice. Let's have a look at the background with the automatic background extraction placed on top. And this is what we see. Yeah, there definitely was structure in there that has been removed and nuked by Graxpert. So we do need to be careful there. And if I use Graxpert with the smoothing of 1, which is what I would always recommend to use to avoid this kind of structure blasting, we get those gradients are still on the side of the image. So I would probably need to kind of like crop it a little bit, or maybe try with a smoothing of 0.5 while really looking at how the background is behaving. This is the background details with that smoothing of 1. And this is, definitely we're not removing any gradient, which is a good thing. We also see that maybe this gradient at the top and the bottom are stacking artifacts, so they might be my fault. And what about our automatic dynamic background extraction? Let's have a look at the results. And in my opinion, it performed beautifully. It managed to remove all of those gradients to the outside of the galaxy. And let's have a look at the details of the background it extracted. It actually seemed to have maybe put some points on the galaxy. We may want to check that, but overall, I think it's working pretty well. And we can confirm that again by looking at the History Explorer for the M31 with automatic dynamic background extraction and look at the sample points that were taken. Probably kind of a small false alarm. I do think that this sample here is a bit too close to the main body of the galaxy, and this one as well is like in the nebulosity that streaks away from the galaxy in one direction. I probably would remove a couple of those samples, but overall it's performing extremely well, and it has found relevant samples for the image without me having to do anything. And I do kind of love that. Do you think the automated dynamic background extraction tool is something that you'd like to use instead of Graxpert? Let us know down in the comments. And while you're at it, like, subscribe, join my Patreon, become a channel member, or if you're buying anything from all of those stores that I have in the description, click on the link and then buying will help me at no cost to you. But anyway, I find this fascinating, and I will add automated dynamic background extraction to my workflow because I feel like in a lot of cases it can perform as well, if not better, than Graxpert AI. And I can tell exactly what it has done and what points it has chosen, and I can define like forbidden areas, which I think is amazing. That's all I have for today, so we'll end the video because it's a 20 minutes or longer video with the list of my Patreon and channel members who make the channel possible. But as always, thank you so much for watching. I hope it was interesting, and I hope it helps with like analysis paralysis of all of the background extraction methods that are available to us now. But more important than all of that, don't forget whenever you can to look up at the stars, and I'll see you next time.